Welcome to the fossil era. I'm Annalee Newitz. I write and edit io9.com, which is a online publication devoted to the future. We cover culture and science fiction. And I also spend a lot of time writing about science as a journalist. So I do a lot of writing that's pretty non-speculative, as well as the speculative work that I do at io9. And a lot of what I'm going to be talking about in this talk is inspired by a book that I've just finished working on that's coming out in May, which is about how humans will survive a mass extinction. And in order to research this book, I had to do kind of a crash course in geology, in deep geological time, because of course, probably most of you know, there have been 5 mass extinctions on the planet before. And so thinking about future ones requires you to kind of go back into deep time and look at what's happened before that. So a lot of the time when I was working on this book, I began to think about this idea that I'm presenting to you today about the slow future. And this is one of the first times I've really talked about this, so I'm very curious to get your feedback. But what I really found was that a lot of the cycles of change that we see happening as a species, but also as a planet, are really taking place in slow time. And I think that we, as futurists, especially over the last 40 or 50 years, have become really interested in what I would call fast time. And I think the idea of slow time really has to be a kind of corrective to a lot of the futurism you see that promises, for example, that, and not just futurism, but also science fiction, that promises that in the next 20 years or 30 years, we're going to be cyborgs, we're going to have hard nanotechnology, we're going to have synthetic biology, we're going to be able to extend our lives to 200 to 400-year lifespans. And I don't think there's any one particular person or group that are perpetrating these myths. I think it's a trend in our thought. And I think that this trend in our futuristic thinking is partly inspired by the rapid pace of technological change. And a lot of our great futurists, a lot of the great futurists of our generation have come out of computer science and out of technology. And so their model for how change happens is this hyper-accelerated technological model. And so what I want to do today in the next few minutes is offer you a couple of other models for understanding how change takes place over time and what different timescales might be that we need to think about alongside these rapid changes that we see in technology. So there's 2 problems I see with that promise of a near-term, radically changed future, the future where we all become cyborgs and everything is awesome. The one problem is, as futurists, as writers, we overpromise a future. And so we lose the respect of our audience. We lose the faith of our audience. We lose the ability to convince people that our ideas have any kind of validity because we overpromise. We say things are going to come to pass that don't. The singularity was, I think, supposed to happen a couple of years ago and it hasn't. And so people start to get restless and not pay attention to our very, I think, valuable contributions to public discussions over where we should go as a civilization. But even more importantly to me, I think that when we think only in terms of this fast future, we become unable to prioritize what's important. What's important in terms of what we should advocate for as writers and futurists, but also what we should be doing in the areas of science and public policy to make humans survive for another 1,000,000 years. To keep us alive for another 100 years. And so we have to be thinking in terms of that prioritization. At least for me, I think that's a really big part of what we can do that's helpful as futurists, to sort of say to people, here's what you want to be focusing on. So, all right, I have this great, I love this illustration. This is an illustration of geological time. If you're not familiar with the geological eras, it's a little crash course in how long things have been going on in the past, 4.5 billion years on Earth. So geological time is a great model for another timescale of change. It's exactly the opposite of the timescale you see with technology development, right? It takes place over millions of years or billions of years. It took 2 billion years for multicellular life to evolve after unicellular life. So, things take time. This is also the time scale at which a lot of climate changes occur. Climate changes occur over millions of years. They get corrected over millions of years. Certainly there are periods of accelerated climate change, but even accelerated climate change takes place over hundreds of years. And then again, it often takes millions of years to correct itself, or to change. Maybe not correct itself is not the right term. So the reason why it's important to think about this other time scale of millions and billions of years is that a lot of the science that we're excited about as futurists and as people today is dependent on observations that grow out of geological observation. Things like understanding climate change, how we might intervene and do geoengineering projects, but also things like material science. A lot of material science, which is basically the way scientists refer to things that in futurism often get called nanotechnology, just ways of understanding how matter is composed, how atoms behave under different circumstances with each other. A lot of that is dependent on observation of the geological world. And observation of the geological world takes time. It's not like improving a microchip. So it's important that when we think about how discoveries will unfold in fields like materials science, nanotechnology, things like that, that we think in those longer terms. I'm not saying think in billions of years, because that would be, I think, too long, but definitely be thinking about the fact that in a human lifetime, you may not be able to observe enough about the natural world, the geological world, to make those kinds of leaps that will get us a nanobox that will build you Earl Grey hot. So, sorry, that was a Star Trek joke. That may happen again. So another long-term way of thinking about time is to think in species time. So geological time is the time of these carbon cycles, these large-scale Earth transformations. Species time is the amount of time that a species exists on the planet. And for mammals, we're a mammal, which is why we're awesome and furry. The average life expectancy for a mammal species is 1 million years. So either after that million, that's average, so some may be longer and maybe shorter. Humans have been around, 200,000 years. So we're early in our cycle. And the thing is that what happens after that 1 million years is either the species goes extinct or they speciate, they might become multiple species, which I hope humans will do at some point, or they evolve into a new species. So like 1 million years ago, Homo erectus was our ancestor, hanging around on Earth, looking pretty much like us, acting a lot like us, using fire, punching each other, things like that, and we still do that. And now, of course, we're Homo sapiens, and so we evolved out of that. So Homo erectus had its time, and now Homo sapiens is having its time. So I think it's interesting to think about this, about species time in the context of space travel, because if you look at the history of the human species, one of the ways that we changed the world and changed ourselves was we started using boats that looked a lot like this, actually, reed boats, to explore the planet. And actually, we started doing that, it's likely about 50,000 years ago. And that's how humans wound up in Australia from Asia about 50,000 years ago. So anthropologists now believe that that was done through boats. It's also now commonly believed, it's still a little bit controversial, but it's commonly believed now that humans also came to the Americas in reed boats, very much like this from Asia. So it came out of Asia, kind of came around all the way down the coast and down all the way into South America. Which means that like San Francisco got colonized really early because it was such a great place to stop off on your boat. So the reason why I think it's important to think about this long, long history of boats being used to change our relationship to the world, to change our culture in the world, is that it took a long time before we had our contemporary culture, which I think is arguably created through, say, the last 400 years of hyper-accelerated development in the area of shipbuilding. It allowed us to create an international culture, it allowed us to create international trade, wound up leading to things like the world we have today, which is of course helped along by things like airplanes and instantaneous communication, where we now have a genuinely global culture. It's not just like a few people went over to the Americas 15,000 years ago. Now we really are everywhere all the time. So that took 50,000 years. So just as a thought experiment, think about what we're doing now in space. We've sent a few probes out. We've sent a few incredibly awesome robots out who we all love, like Curiosity, and they're hanging out, kind of doing what people were doing in Australia and the Americas thousands of years ago. So it's possible that exploring and colonizing space may take a little bit longer than we thought. It's maybe not going to happen in the next 100 years. Maybe it'll take place in a time scale closer to species time, like thousands of years. I'm not saying it's going to take 50,000 years. I think that would be an absurd claim, or hopefully that's an absurd claim. But I do think it might take a lot longer than we realize, because I think that the lag time between developing a viable vessel and actually colonizing a place and turning it into, say, a solar system culture, that may be a very, very long lag time. So it's just useful to keep that in mind. I'm not saying that that's a for sure thing, but just good to think about. And now let's return to human time. Human time, when I was interviewing geologists for my book, a lot of times geologists would say, oh, well, that takes place in human time. They would kind of roll their eyes, because real time is geological time. You know, that's when things are really, that's when like weathering is taking place, which is like, you know, when mountains are being eroded and the carbon cycle is being changed. And so human time is the time that we all know. It's real time. It's what we experience as a species. And for most of us, it's also the time that we've watched computer science and technology absolutely transform the world. So we've seen in human time this dramatic change, something that we can observe, that many of us have viscerally experienced in our lives. So that has become, for most of us in my generation, and your generation probably too, that's become kind of the way that we've measured change over time. Is we think, well, that's how scientific change works, right? It happens observably in one lifetime, unlike, say, the changes that allowed us to become a global culture, which took place over thousands of years, or the changes that allowed us to become a species, which took place over millions of years or billions of years. So we have this comfortable model. We have this comfortable model of how change works. And it's provable, right? We've seen it happen. I think the problem is that we've become so familiar with technological change. It's like a warm blanket. And we think that all change will happen in the same way. And so we kind of confuse human time with species time and geological time. And that's when I think we run into this problem of being unable to prioritize what kinds of scientific projects and social projects we can accomplish in a lifetime versus in many lifetimes or in a species time. So basically when that happens, we make mistakes. We don't look to history to guide us in our priorities of what we want to accomplish. So the question is, given these different timescales, given the fact that we're kind of trapped in this brief human time, how do we reach that shining future that we wish would come in 20 years? Like, how do we reach the future of robots repairing our DNA and robust nanotechnology and space travel? Like, what can we do in a human lifetime that will affect species time or geological time? That really becomes the question, is how do you figure out what you can do now that will then intervene in these much longer time cycles? So what my suggestion would be, and I think there's a lot of answers to this question, and I really want to emphasize that, but my answer to the question is to engage as much as possible in what I'm calling scientific realism, which is basically looking to science to be our guide for how we prioritize what projects we want to advocate. So just to give you a quick example, we should set near-term goals as futurists. And when I say near-term, I mean in the next like 50 to 100 years. We should set goals based on science that exists now. So, for instance, we would like, I think all of us would like food security. We don't want to have mass starvation and food riots. We actually have the technology now to make that possible, for everyone to have food security. That technology exists. We can grow the crops. We have satellite technology that allows us to predict droughts a year or two in advance so that we can know where we have to send in food for people who may be about to suffer from some kind of famine. And we have that technology now. So what we can do as futurists is advocate for the deployment of actually existing technology now to fix this problem, which is a huge problem. This is a Star Trek level problem. How do you solve hunger? And we could be doing it. Now, the opposite would be something like hard nanotechnology, like having the magical box that can build you that Earl Grey tea hot. That is a great long-term goal. I definitely think we should be working on trying to have control of matter at an atomic level. I'm totally in favor of that, but in order for us to have that special box, that replicator, we have to invent a lot of technologies that don't exist yet. They aren't in the lab. If you talk to scientists who are in material science, who are working on these areas, they will not say to you, yeah, right now, if we deployed the technology we have, we could have replicator boxes. We don't have it. So that's a longer term goal. That's a species goal. That's something that may come to fruition in our lifetimes. That'd be great. I don't think so. Based on the technology in our labs today, it's a longer term goal. And I think the same thing can be said about, if you look at the area of climate change, there's short-term goals in climate change. We can aspire in our lifetimes to have alternative and sustainable fuels. I don't think we can aspire in our lifetimes to have robust geoengineering. As much as I would like that, would love robust geoengineering in my lifetime, I think there's going to be a lot of experimentation before that actually happens. I hope it happens in the near term. I think it's more likely to be a species time goal, or even a geological time goal, to be able to intervene in the carbon cycles of the planet in a way that doesn't cause wars and in a way that is actually functional. So to finish up, I'll just say that my goal as a futurist and a thinker is I would like human beings to have their 1,000,000 years as a species. My goal is another 1,000,000 years for humans. I don't care if we're looking like Homo sapiens at the end. In fact, I really hope that my offspring, my distant offspring, are like squid cyborgs on Saturn. I would be a proud parent of those creatures. But what I want is for us to be thinking, when we prioritize our goals as futurists, we should be thinking in terms of what are the projects we can do today to make us survive into tomorrow as a species. So maybe we can solve hunger today, maybe we can work on sustainable cities and sustainable energy, and in the long term, we can work on remolding our bodies and going to space and having geoengineering that actually works. So we have, basically, what I want to leave you with is just the kind of suggestion that as you think about the future, remember that there's many different time frames that the future unfolds in. There's your lifetime, there's species time, and there's geological time. And they're all happening at once. They're all affecting each other and overlapping. They're dialectically related. What you do now can affect what happens in 1,000,000 years. I really believe that. Maybe they don't remember who you are, but like that squid cyborg, they're gonna look back at Homo sapiens and be like, good job, you guys, you got us off the planet. Just like when we look back at Homo erectus, we're like, go you invented fire and tools, you got out of Africa, you did a good job. So I think there's gonna be that connection, but we always have to keep in mind which are the projects happening in which time frame. So that's what I wanna leave you with. Thanks very much.
We have time for one question.
I'm going
You can
for
select.
All right, TJ.
So, what would you think then about the term Anthropocene?
I say go for it. I mean, I think,
Well,
I always,
do you think we're in it, or do you think we haven't approached it yet?
well, I think we're clearly in it. I mean, I think the reason why people talk about the Anthropocene is the idea that humans have intervened enough in geological time that we've actually changed the carbon cycle, very likely. And usually the way that geological time periods are delineated is through some kind of dramatic change in the climate or in the ecosystems. So I do think it's reasonable to say, yeah, I mean, geological time is weird anyway because like we're in the tertiary because humans evolved at the beginning of the tertiary. We're so like human-centric, right? Like, oh, because we came along, now we're in a new geological era. But I actually do think that that we are in the Anthropocene, and I think we should take that seriously and take control of it over the long term, and make sure that we maintain a climate that's good for us and all of the food webs around us. I just don't know if we can do it in the next 10 years. I think that's a long-term species project. And I'm up for it, so if anybody's doing that, I'm down.